That's how you check it. What? No.
I don't know what happened to, here it is. Okay, so like I said, we're going to pick up here at the sum and difference rule. I'm going to try and go slower, especially when we get to that trig section, just because it's not actually that bad, but I know that y'all get really nervous when it comes to the trig stuff. So we might not finish this today just because we're going to intentionally go slow. Okay? But on the sum and difference rule, so like I said yesterday, your sum or difference rule means that your derivative of, and it's like a value f of x or g of x, and they're added together and taking the derivative of that would be the same as if you took the derivative of the f of x and then you took the derivative of the g of x and then you added those together. It's going to be the same value. And the same would apply if you were doing subtraction. So, in order to do the sum or difference rules, we're also going to integrate these previous rules that we just learned. Okay? So, looking at, and I'm going to separate this out, actually. So, looking at A. If I look at just my first part, and I look at the x cubed, I would go to the power rule, which was rule number 3 on this last page, and I would find the derivative of x cubed. So remember the rule for that was, I think it was just n times x to the n minus 1 power. So right here I would do, this is 3 times x to the 3 minus 1 power. Then I'm going to do my next one. So on negative 5x squared, I'm going to do my general power rule. So I'm doing minus, and this is negative 5 times my n, which is 2, times x to the n minus 1, which is 2 minus 1. Now I'm doing my plus 2x. So on this one, I'm going to be using my, you could call it the general power rule. You could also call it rule number 2, which is your single variable rule. Okay, so the x itself is going to come out to 1. And so I have 2 times 1. If you remember yesterday, whenever Franklin asked, if you had a slope of 2x, would it be just 2? The answer is correct, yes. Yes, Logan.
So, would it be plus and then you kept the minus inside? Or is it, because if you have the 2 minuses, wouldn't it be positive, but it wouldn't be a plus instead? Or, so, because you have the minus 5x, you have the minus outside, but it's also negative inside too. This was
You're right. This should be a plus 5 because I'm keeping it out. Or you could do plus and this is going to be negative. But you are right, Logan. It should be, when it's all said and done, yes, you are correct. Put this back at a 5. Plus 5. Okay, and then the last one on negative 7, we're going to be doing the constant rule. Did Jack find you to get his backpack?
Is it in the old gym?
No, so he left it in the hallway, and the janitors put it on top of the lockers. It's literally sitting on top of the lockers in between.
Lockers?
The old lockers? No, it's not in the old gym. It's in the hallway.
It's still called the old gym.
There's no top of the lockers, though.
That's where I saw it. So, the gray lockers, and it's in between the costume room and the cheer room. I saw it sitting on top of the lockers.
Further down. I'm sorry. I looked in the very front right there. Sorry.
No, yeah. Okay. Sorry, guys. Okay.
Sorry to interrupt you on math, Mom.
You're good. The constant rule, so I have a constant, I have minus 7 here. Remember, a constant slope is going to be 0. So we're adding 0 here, or subtracting 0. And this is f prime of x we just did. Okay, so we're going to act this all out, okay?
Wait, so how does the 7 become 0?
Because it's a constant. So if you go back here, I'm going to flip it real quick. Okay? If you have where it's just a constant value, so for example, C here would be 7, okay? The derivative of that equation, y is equal to 7, is just 0 because the slope would be 0. Okay. So here we have 3 times x to the 3 minus 1. That comes out to 3x squared. Then I have minus 5 times 2, that's 10x. And then I have plus 2 and minus 0. So my answer is 3x squared minus 10x plus 2. Okay, so let's do the next one. Y prime. Okay, so on this first one, we're going to be using our general rule. I'm just going to put number 4 so that it's easier to read. Okay, so I'm starting with a times n, that's 2/5 times 5. And then I have x to the 5 minus 1 power. Moving on to our next one. We have x to the 4th power, so we're going to be using our power rule. So I'm doing x to the 4 minus 1 power. Actually, you know, it's 4 times x to the, we're just going to add a 4 here, it's okay. Okay, next we're going to be doing, so actually this is number 3. We're going to be doing rule number 4 here again. So I'm doing 3 times 2 times x to the power of 2 minus 1. And then lastly, I'm subtracting 1, but that's a constant, which means I'm subtracting 0. So that's rule number 1 here. So moving on down, y prime. I have 2/5 times 5, which is what? 2. And this is x to what power? 4th. Okay, over here, I have plus, this is x cubed and 4, so 4x cubed. And then right here, I have 3 times 2 times x to the 2 minus 1 power. This comes out to 6x. Yes?
So, is the sum difference rule just everything else before it combined?
Yeah, it's like, I would prefer the word integrate. Like you're taking all those rules and you're putting them in together. But yes, I guess combine is okay. Okay. Well, because you're not really, okay. What are you pointing at?
The integrals.
Like integrating?
Okay. Latin words over here. Okay. Okay, anyways. Okay, so on this one we have to rewrite it to make these rules apply. So this is x to the 1/3 plus 5x to the 1/2. So on our first one, we're going to be using the power rule. So I'm doing 1/3 times, this is x to the 1/3 minus 1 power. Plus, on this next one, we're going to be doing the general power rule. So I have 8 times n, so 5 times 1/2. times x, and this is going to be to the 1/2 minus 1 power. We're going to make some ugly fractions. Not as ugly as yesterday, though. Okay. So first off, I have a 3 in the denominator. Then I have x to, what power is that going to be? Negative 2/3. If it's a negative power, then it goes where? Denominator. And then I just have 1 in the numerator. Over here, I have 5 times 1/2, which is 5/2. And then that's going to be x to what power?
Negative 1/2.
Negative 1/2. So we're going to do the same thing and put that in the denominator. Do I need to rewrite any of these? I guess the only one that has to be rewritten is this one. This is 4x to the negative 1. But otherwise, the rest of those are fine. Okay, so y prime here. We're starting with our general rule, so we're doing a times n, which is 5 times 3/2, times x to the n minus 1, that's 3/2 minus 1. Okay, now we're subtracting. I'm going to put that all into parentheses so it's just clear. So this is another general rule. We're doing a times n, which is 6 times 5/3 times x, and this is 5/3 minus 1. And then last one. This is 4x to the negative 1 power, so we're doing, another general rule. So I'm doing 4 times negative 1. Oh, come on, Rick. Times x to negative 1 minus 1. Okay, so starting with our first one, 5 times 3/2. It's not 10.
It's not 15/2.
15/2. Okay, and then what is my x?
X to the 1/2.
X to the 1/2. You could also write that as a square root of x. Okay, so now we're subtracting. 6 times 5/3 is what?
10.
10. Okay, and then what is my x to the power of? 2/3. And then this one. Okay, so I have 4 times negative 1, which is negative 4. And then this is x to the negative 2 power. So let's write this as a fraction instead. That is 4 over x squared, or negative 4 over x squared. And boom, we have a y prime. Not too bad, right?
Yeah, it's stuff.
Okay.
Haircut looks tough. I think it's tough.
I think it's tough.
I didn't realize that y'all were Daniel's pep squad.
I don't know.
Hype him up is right.
That's how
She thinks it's tough too.
Okay, moving on to E. So let's rewrite these two for sure. Our first one's okay, so 3x squared is fine. Okay. This is 4x to the negative 2. And this is 2x to the 1/2. We're going to use the general rule on all of these. So I'm doing a times n, which is what? 3 times 2. And then x to the 2 minus 1. Okay, we're subtracting here. We're doing a times n, which is 4 times negative 2. And we have x to negative 2 minus 1. And the very last one, we're doing a times n, which is what? 2 times 1/2. And then x to 1/2 minus 1. Okay, so my first one, I have 3 times 2 times x to 2 minus 1. What's that going to come out to? 6x. Okay, over here I have minus. This is 4 times negative 2 times x to negative 2 minus 1. What's this going to come out to? 8. 8x to the negative 3 is right, so we're going to take that. Well, it's also negative 8, so this is going to become positive because I have 2 negatives. We're going to take that x to the negative 3 into our denominator. Okay, and last one. I have 2 times 1/2 times x to the 1/2 minus 1. What's this going to come out to? 1 over x to the 1/2. You can also rewrite this as what? It is correct. Okay. Let's rewrite this one. I'm just going to make it clean so we don't run out of room. I'm going to go ahead and divide x into all of these. So 8x cubed divided by x is what? 8x squared. 4x squared divided by x is? 4x. Okay. And then I have negative 3 divided by x. Negative 3 over x, or we could write this x to the negative 1. That way we can work it in these rules. So what rule are we going to use on 8x squared? General. What rule are we going to use on 4x? You could use the general, but one would be much easier. Not the power. No, not constant yet. The second one, the linear rule. Yeah, okay. And then here we're going to use which one? General. Okay.
Yes.
Do you have to have them memorized? I don't think.
Aren't they all just like the same?
The general rule can work on everything. You're correct. That's why it's called the general rule. But yes, the other ones are more shortcuts. Okay. Anyways. Okay, so starting here on 8x squared. Let's try to not write it out. Okay. I have a times n, which is what? 16. And then it's going to be x to 2 minus 1, which is going to be x what? To the first. So this comes out to 16x. Okay, now let's look at our 4x. So we're using rule number 2. So the x itself to the first power is going to come out to 1. So what am I putting down here? 4. Okay. And then my very last one, I'm subtracting. Well, actually, let's just do this. So I have 3, a times n, which is 3 times negative 1. So this is coming out to, what's 3 times negative 1? Negative 3, and we have a subtraction, so this is now positive, okay? Then my x, I'm doing negative 1 minus 1.
0.
Negative 2, which means it's going where? To the denominator. So what's my final answer here?
16x plus 4 plus 3 over x squared.
That's correct. Y'all are so smart. You are so smart. Okay. Okay, so now we're moving to the dreaded trig. I don't know what you're throwing at each other, but you need to stop that. Okay. Okay, so derivatives of sine, cosine, and tangent functions. Okay, I'm going to go ahead and give you the answers. Anytime that you are taking a derivative of sine of x, it will be the cosine of x. Well, we're going to prove it to you in just a minute here. Patience, Franklin. Okay. Anytime you're taking the derivative of the cosine of x, that is going to be negative sine of x. And when you take the derivative of the tangent of x, or tan of x, then you're going to be getting secant squared of x. Okay, so right here at our example, this graph is our y sine of x, or it's going to be a sine of x graph. And right here is our cosine of x, which is our y prime. Okay? To prove that, we're going to look at this actual graph. Let's start with y sine of x. Y is equal to sine of x. Okay? Look at your graph from here all the way to pi over 2 is increasing. When you get to pi over 2, I hit the relative max, and what's my slope at the relative max? 0. Which means I'm going to start what, Logan? Decreasing. So from pi over 2 to 3 pi over 2, I'm decreasing. And I cannot write at that angle. It's okay. Until I get to my relative minimum, where my slope is what? 0. And then I'm going to switch back, and I'm going to move to increasing. Okay? So remember, when we're taking the derivative, what are we finding? The slope of the tangent line. Okay. So right here, on this one is my y prime, which represents the y as the slope of the tangent line. Okay? So let's first note 2 things. Number 1, let's note where my slope is 0, which is going to be at pi over 2 and 3 pi over 2. Look over here on the cosine of x graph. At pi over 2 and 3 pi over 2. What are those? Zeros. They're x-intercepts. Okay, 0 was not a bad answer. Okay. So my slope of the tangent line on this graph was 0. And so over here, those zeros formed x-intercepts. The other way to look at this is look at where it is increasing versus where it is decreasing. Where it's increasing means that this value of the slope is going to be above 0, meaning it's going to be a positive number, anywhere where it's increasing. And where it's decreasing, my slope is going to be a negative number, meaning it's going to be below, did I say below 0? Above 0 over here on increasing. On decreasing, it's going to be below 0. So those all match, which mean when you look at these graphs, you can tell that cosine of x is the graph of the derivative of sine of x. Does that make sense to everybody? Okay. What doesn't make sense, Franklin? Okay, that makes me nervous. Okay. Graphing a derivative is not that much more than what you've already done. Okay? But I can prove this to you in your calculator. So you're going to go to Math 8. Okay, you're taking your derivative of x, and we're doing sine of x. Oh, I'm sorry. Okay. And then I don't know what my window looks like. Okay, cool. So here's my current graph for my derivative of sine of x. If I went in here and I just put in cosine of x, those should be the exact same graph. And you can prove it here in your table. So it checks out. Okay? If you have a different calculator than me, then follow that one. I don't really know what that means. Okay. Even more fun stuff. Okay. I know that it says recall. It's going to be okay. But on example number 5. Okay? Using the limit definition for the derivative, which is our f prime of x is the limit as h approaches 0 of f of x plus h minus f of x divided by h. Using that limit definition, we can derive that f prime of x for each of the following trigonomic functions. We're going to verify the derivative for sine and cosine, the same thing we just looked at the graphs for, by using the sum and difference formulas that we learned in pre-cal. It's okay. So, first off, we're going to establish these two rules. If you have the limit of h as it's approaching 0, and you have a sine of h over h, very similar to your sine rules, this is going to come out to 1. If you have the limit as h approaches 0 and you have cosine of h minus 1 divided by h, this is going to come out to what? 0. Good job, Franklin. Okay. Let's start with, I don't know which one to start with. It's okay. Okay. These are some rules from pre-cal. It's okay if you don't remember it. It's okay. 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 If you have a cosine of x plus h, you can rewrite this in this way. It would be cosine x cosine h. Because you have a plus symbol in here, you're going to switch this to a subtraction. And then we're doing sine of x times sine of h. Okay? The other one, if you have a sine of x plus h. For this one, you're going to rewrite as sine of x cosine of h.
I'm percentage of this, but
It's okay. That's why I said we're going to go slow, okay? Plus, we're doing cosine of x, sine of h. So on this one, you're keeping the cosines together and you're taking your two variables x and h, and then you're keeping the sines together and your variables x and h. On this one, you're almost like switching them, right? So you have sine for x, cosine for h, and then over here you're going to switch them and you're taking the cosine of x and the sine of h. Okay, so we're going to use all four of these to prove that the derivative of sine of x is the cosine of x. Yes.
So with this, will the signs ever change from x plus h?
Yes, so normally it's x minus h, and then it would have been a plus, but because this was a plus symbol, we had to switch the symbols.
So they're the opposite for the cos and the same for the sine?
Yes. Okay. Okay, so on A, we're going to show that the derivative of sine of x is equal to the cosine of x. So, we're looking for f prime of sine of x. Remember that we're going to be using our limit definition for the derivative, which is up here at the top, so I'm going to highlight it real quick, which is the limit as h approaches 0 is f of x plus h minus f of x divided by h. Okay, so back down to here. I have my limit as h approaches 0. So we're taking sine of x plus h minus sine of x over h. So now we're going to take this rule for sine of x plus h and we're going to add it in. So I have my limit as h approaches 0. This is probably not going to be a long enough line, but it's okay. So I have sine of x, cosine of h. Plus cosine of x, sine of h. It's one of those fun math problems where there's no more numbers. Okay, and then we have a negative sine of x by her lonesome. And this is all over h. Okay, now we're going to try and separate these and manipulate this formula to where we can get some ones and some zeros in there, where we can cross some stuff out. Okay? So let's start with let's do this negative sine of x and this one together because they both have a sine of x. So I'm going to, I keep forgetting what that word's called. It's like the opposite of distributing. It's fine. It's whatever. Okay? And so what I have left over here is I have cosine of h. And then here I have a negative 1 left over. And then I didn't touch this one, so I'm just going to rewrite cosine of x, sine of h. And this is all over h. Okay, now I'm going to, I probably could have done that last one, but it's okay. Now I'm going to separate these into two fractions. So over here I have sine of x cosine of h minus 1. And then over here I have cosine of x times sine of h over h. Okay, so we're going to use our two rules from above here. So let's start with on the left. We have a sine of h over h is 1. Is there somewhere we can make a sine of h? Yes, right here. Sine of h over h is 1, which means this is going to cancel out to become just cosine of x. Okay? Do we have somewhere we have cosine of h minus 1 over h?
Yes.
Yes. This is going to cancel out and become what?
0.
0. What's sine of x times 0? 0. So my f prime of sine of x, oh well, comes out to what? Cosine of x. I'm putting in parentheses, I don't care. Yeah.
Could you re-explain how you got the cosine of h minus 1?
So I took, let me use a highlighter. Okay, I looked at right here where I have sine of x times cosine of h. And then I took this negative sine of x right here. And I'm Googling it right now. What is the opposite of distributing called? Because I keep forgetting what the word is. Okay. That's this, ignore that. That's the script for theater. Is it just factoring? Surely not. Okay, whatever. Okay, we're factoring. Okay, so I took these together and I saw that they both had sine of x. So essentially, like if I pulled out a 2, like if it was 2x, or like 2x squared plus 2x, and I pulled out the 2x, right? I did the same thing with the sine of x. So I took this out right here, and I was left with cosine of h, and I was left with negative 1. So like this whole process is basically like you manipulating the numbers. Okay, so we have 3 minutes left. I don't think we can do the next one in 3 minutes. Although, other than the fact that we didn't get to, you know what, it's, no, I don't, well, I'm going to start it, but I don't think we're going to finish it. It's okay. I didn't think we were going to get to the last page today, though. Okay, but this would be f prime cosine of x, and pretty much we're doing, on this one, we're proving that the cosine of x is negative sine x. Okay? I think I really only have time to write this out to where we can start it on Monday. So this is cosine of x plus h minus cosine of x over h. And so here we would replace this with that big one we wrote up there. And we'll stop after this line. Okay, so on this one I have cosine of x times cosine of h minus sine of x times sine of h minus cosine of x all over h. Okay, and we'll pick up here on Monday and finish this one out. Okay, I hope that wasn't too bad.
Pretty wet.